Calculating new tool and material characteristics. Under the Material Properties Detail section of Speedcast, there are two key values: the cutting stiffness and the process damping wavelength. Essentially, they are the forces required to push that tool through that material. The approximate values included in Mil-Max are often sufficient to get you the correct process predictions. However, more precise values may be necessary in some instances. For example, additive manufacturing has enabled the creation of new alloys that require finish machining with no known cutting data. Manufacturers are creating new tool geometries are designed to increase process damping or change the direction of the cutting forces. Generally, cutting force and process damping coefficients are determined experimentally using the tool and workpiece material in question and measuring the force during cutting using a dynamometer. However, with Speedcast and Harmonizer you can replicate this high-level tool and material testing in the field. This testing method is for indexable milling cutters and slotting-capable end mills. For high depth of cut and low width of cut, less than 25%, refer to the lesson on optimizing HSM end mills. Click links in the upper right of your screen, and then open Calculator. Select the closest ISO material code to the material you are testing. Tap Test the cutting tool and generate a dashboard with Mil-Max using the same ISO material code as on the calculator. Note that you do not necessarily need to perform these tool and material characteristic testing on the same machine as your customers or even with the same tool holder. The resulting cutting stiffness and process damping values can be applied to future tap tests of the same geometry cutter, even of different diameter and lengths, in the same material. Also, a very short end mill and a short tool holder may not produce discernible red zones required for this testing. Use a longer version of the geometry tool and or a longer tool holder. Set the width of cut to 100%, or a full slot. Lock the width of cut by checking this box. Adjust the axial depth of cut so that there are clear stable, in green, and unstable, in red, regions of speed. If only red zones appear, lower the depth of cut. If only green or only green and yellow zones show, keep raising the depth of cut until red zones appear. Dial the spindle speed to the lowest stable zone, and determine the speed where the chatter status transitions from stable green to conditionally stable yellow. 753 revolutions per minute in this example. Enter that speed into the calculator under number 1, transition speed. Dial the spindle speed up to the middle of the highest red zone that is between two green zones. Be sure to respect the surface feet per minute limits from the cutting tool manufacturer. Enter that speed into the calculator under number 2, chatter speed. Maintaining 100% width of cut, increase the axial depth of cut until the fastest stable pocket becomes very narrow. Adjust speed dial to the center of this green zone. Enter that depth of cut into the calculator under number 3, maximum depth of cut. Maintaining 100% width of cut, lower the axial depth of cut until the entire dial turns green. In this case, it is 0.03. Enter that depth of cut into the calculator under number 4, minimum depth of cut. Now you are ready to perform cutting tests. You will use the harmonizer to record each pass and to determine when to stop as soon as chatter is detected. Make full slot test cuts, at incrementally increased depths, as shown on the calculator. Conduct the test passes at the same RPM shown on the calculator, and at the calculated progressively deeper cuts. When chatter is detected by harmonizer, choose chatter from the drop-down menu next to that depth of cut. If you complete cut 8 with no chatter, double the DOC from cut 8 and enter it into number 4, minimum DOC. Next, make peripheral test cuts, at incrementally faster speeds as shown on the calculator. For the next set of test passes, use the same depth of cut from the calculator and at the progressively faster calculated speeds. When chatter is detected by harmonizer, choose chatter from the drop-down menu next to that speed. If you complete cut 8 with no chatter, multiply cut 8 RPM by 0.75 and enter that value into number 1, transition speed. New cutting stiffness and process damping values will be automatically calculated. Next, we will add this new material and properties to the materials database. Open Mil-Max and click on the Setup button. Click on Materials Details button. Check the Show All Fields box. Choose an existing materials database or enter a new name to create a new one. For example, if the tool is from Kennametal, you can name the materials database Kennametal. Click Add. If you are creating a new database, click Yes.